So we're going to look at absolute value and inequality. So we're going to start with absolute value. And remember that the absolute value is a distance. So this is saying the distance is 2. So on a number line we would see that like this. If here is 0, then if we travel 2 away from 0, we're at either 2 or negative 2. So the answer can be either plus or minus 2 for this. So what you usually see as an absolute value is that whatever number is inside the absolute value is made positive. And that's true, and that's because it's a distance. Okay, so either absolute value of 2 is equal to 2 or negative 2 is equal to 2. Now if we make the inside a bit more complicated, then we're saying that x plus 1 has to equal 3, or, so the inside of this bracket, if that's a 3, then that would work. But if the inside of this bracket is a negative 3, then that's also equal to 3. So the inside of the bracket x plus 1 can either be 3, or the inside of the bracket x plus 1 can equal negative 3. And that will give you your two equations to solve. So x is equal to 3 minus 1, which is 2. So 2 should work. Or x is equal to minus 3 minus 1, which is negative 4. So we get two answers for an absolute value. We could check our answer by plugging each of those in. So we had x plus 1, so 2 plus 1, which is 3. And plugging in negative 4 plus 1 gives me the negative 3. Alright, so let's see a few examples of this. So I'm just sticking with the 3 for now. So this is saying that the inside of this bracket can either be plus 3 or minus 3. So that's our two cases. So 2x plus 4 equals 3, or 2x plus 4 equals negative 3. And rearrange these. So 2x equals 3 minus 4. Or 2x equals minus 7, x equals negative 7 over 2. Okay, and with fractions, it's not always fun to check your answer, but we can check our answer by plugging the minus 1/2 in. And seeing if that's equal to 3. So 2 over 1, so this is negative 2 over 2, which is negative 1 plus 4, or 3. So that one works. If we plug the negative 7 over 2 in, we'll end up with the negative 3. So 2 times negative 7 over 2 plus 4. The 2's cancel. Negative 7 plus 4 is negative 3. Alright, so let's do another example that we put a fraction into the absolute value. So here, the inside of the bracket has to either be plus 6 or minus 6 because we want a distance of 6. So 2x plus 1 over 4 equals 6, or 2x plus 1 over 4 equals minus 6. And we're going to solve these. So remember, when you have a fraction equals a number, you cross multiply. 6 times 4 is 24. And then we rearrange it. So there's our first answer. Same thing here, except that will be a minus 24. Stick an or in between because it's one answer or the other. Either of those will work, and there's our two answers. Now sometimes we'll get an absolute value is equal to, say, 0. Well, the inside can be 0, and minus 0 doesn't really make sense, so we just say is equal to 0. So x equals 1 would work in this case, and then you would just have one answer. So when it's equal to 0, we only have one answer instead of two. Okay, so when it's equal to 0, that's what happens. And then the other case is if we had an absolute value is equal to a negative number. Well, since it's a distance, it can't be negative, and this won't work. Can't have a negative distance. So if that ever happens, that you see that, we would just go right to saying no solution, and there would be nothing to solve. You would actually get an answer if you solved it equal to -1, but that wouldn't work because the absolute value of anything is equal to a positive. So that would give you no answer. Okay, so let's go to inequalities. So if we had an inequality, say x is greater than 2, then that's saying that all the values that are greater than 2 will work. Now, be careful how you draw this. Okay, so what we've got is x is greater than 2. So the difference is that we could put this little line under, which means equal. So this is x is greater than, but not equal. And on a number line, we show the not equal by putting a circle. This one says that x is greater than or equal to. So on the number line here, when we show the 2, we would actually color that dot in, and then to show where we're going, we make the line a bit darker and shade it in so that that's obvious. Now we can have equations that involve two inequalities. So we could say that x is less than -1 or x is greater than or equal to 2. So on a number line, less than -1, so that goes down. If you think of the end of this arrow, it goes the same way as that, so that's pointing down. Or x is greater than 2 or equal. There is an equal sign there, so this one is not equal, and the 2 is equal, so greater than 2 would go this way, and that would be your solution. And you can't combine these in any way, so you can't put them into one. When there's two separate pieces, there has to be two separate inequalities. So when can you put them as one inequality? And that is when they're in between two values. Let's say we wanted the numbers in between -1 and 2. So this is saying equals -1 and equals 2. And there's no arrows on these because they're just the values in between. So this is red. When you're reading this, we don't read it from left to right. You actually read this as x is between -1 and 2. So when you see that equation, you just want one equation. If we were to split this up, we would have to say that x is greater than or equal to -1, and, that's the important word, and also less than or equal to 2. This is equivalent, is the same thing as saying that. Okay, that and word makes it both true, so it has to be in between them. Okay, so let's make a little table of some different possibilities. So if I give an inequality, and then the number line, and then on this side we're going to give the inequality again, but in set notation. So there's two different ways that we can write an inequality. So I personally like the inequality way, this way. So if that says x is greater than 2, here's 2, 3, 1, greater than 2, be in that direction. And the inequality would say 2 to infinity. So it starts at 2, the round bracket actually means not equal, and then going to infinity, which means go all the way in that direction. So if I put a greater than or equal to, say, 5, at least put one number on each side, we would color in the 5, and we would say, instead of the round bracket, we put a square bracket, and that means equal. So that equal sign is the square bracket all the way to infinity. Alright, so then if we said less than, say 1, here's 1, 0, 2, so less than but not equal to 1 would go in this direction. So that goes all the way to negative infinity. And we always put a round bracket on the infinity, and it goes all the way to 1 with a round bracket because we don't want it to be equal. Now when we write it in between, so let's suppose we said that we want the number between 1 and 2. So here's 1, here's 2. We had an equals for the 2, but a not equal for the 1. So we would color in between, make that line a little bit darker, and the 1 would be a round bracket, since it's not included, and the 2 would be a square bracket. So this would be like a mixed inequality. Alright, so we can have any sort of combination. Now this, when we have an inequality that goes in opposite directions, say we had 0, or say 1, sorry, and not included, and then the 2, let's say, is included, but we're going in the opposite directions. So remember I said we have to write that in two different inequalities. You can't write it in one. So this would say x is less than 1, or x is greater than or equal to 2. And that or, over in these inequalities, we would say negative infinity to 1, not included, and then we actually put this big U. It's a union symbol. The 2 is included all the way up to positive infinity. So this symbol is called a union, and it means or. Okay, so those are the two different ways that you could see inequalities written. Alright, so let's solve a couple. We do it in the same way as there is an equal sign. We're going to keep the x on this side, move the 1 over. 5x is less than 7. And then we would draw this on a number line. So this, if there were a 10 on top, that would be 2, and a 5 on top. 5 over 5 is equal to 1, and 10 over 5 is equal to 2, and that's in between them. So it's somewhere in between, right in the middle of 5 and 10 would be 7.5, so it's a little less than half. And we're saying less than, so we're going to go in this direction. There we go. Okay, so our second example, 2x plus 3 is greater than or equal to 19. So in the same way, 2x greater than or equal to 19 minus 3, so we bring that 3 over. Divide both sides by 2. So greater than 8 or equal. So color that in. And we go in that direction. Okay, so when we answer an inequality, we actually always want the x to be on the right-hand side when we answer. So we either say x is greater than 8 or x is less than 7 over 5. We don't reverse that. So what I mean is we don't say 7 over 5 is greater than x. We don't write it this way. You always put the x first. So if you ever ended up with this, you have to look carefully when you reverse it that it's still, say, pointing to the x, so it's still pointing to the x. Now, in this example, let's just move the x's to the left-hand side. And we end up with minus x is greater than or equal to minus 5. Now, if you remember from high school, when we divide by a negative in inequalities, we actually have to switch the sign. So this would be wrong. That won't work. If we check our answer here, so how do you check these? Plug in a number bigger than 5, so say 6. And if we plugged 6 in, here we get 12 plus 1 is 13 on this side. And on the other side, we'll get minus 4 plus 3 times 6. Minus 4 plus 18 is 14. And the inequality is this way. So it's saying that 13 is bigger than 14, which is not true. So you really have to remember that to change the sign if you divide by a negative. So that's what's different about inequalities versus just regular equal sign. So we divide by a negative, we need to change the sign. So this sign, instead of pointing away from the x, is going to now point towards the x. So x is less than 5 is the answer. And if you check a number less than 5, it will work, like 4, 3, 2, 1, 0. So one way to be sure that you're remembering that is just to always check your answer. Pick a number smaller or in the region that you're saying, plug it in and make sure that it works. That would be a way to check that. And the other way to do it is just to always move the x to the side that makes it positive, and then that would be another way to check so that you're not making that mistake. So let's do another example. Okay, so for example, we had something like this. So there's a bracket. So we're first going to multiply out that bracket. 5x minus 15. Now, what I was saying in the last question was, if you want to avoid that negative, always move the x's so that they're positive. So if we move the 4x over here to this side, and the negative 15 to this side, plus 15. Leaving the 5x and moving the 4x over here, then that makes that x positive, so we don't need to worry about switching the sign, but this is backwards, so you still have to switch the sign by switching this around. So 16, and we want less than or equal to 16. Whoops. So we could check our answer by plugging any number less than 16 in. Let's plug in x is 10. 10 is less than 16. So on the left-hand side, and on the right-hand side, we get 35. So 41 is bigger than 35, and our sign goes in that direction, so that's true. We have it going the right way. So this would be your solution. Okay, and so then the next idea here is that if we had a system of inequalities to solve, so we have more than one inequality. So here they're saying or. So they're saying we want a number x that we can plug into this one that makes it bigger than 3, or this equation less than 2. But it doesn't have to work in both, just one or the other. So all the answers to this one will work. All the answers to this one will work. So, for example, if we solve each of these separate, so x is greater than 1. So any number greater than 1 will work in this equation. Now if we solve this other equation, that's a positive 3 on this side, it would be a negative 3. Less than negative 1 works in this equation. So let's just make a number line. So here this is saying greater than or equal to 1. Or equal to 1. Less than or equal. So we're saying anything in here works or anything in here works. So we would just say x is less than or equal to negative 1 or x is greater than or equal to 1. That would be your solution. Now what if we had the same question but it said and? So we're going to leave this one here just so we can still see it. So the same question, but if we put an and. So now it's saying, okay, this one gives us x is greater than 1, and this gives us x is less than or equal to negative 1, but those don't overlap. So here's the 2. So the problem is we want something that works both here and here. These numbers don't overlap. So this question actually has no solution. The intervals don't overlap. So there's no solution to that. Okay, and then we'll see more of these options later. But basically, when you've got two equations, you want to solve them separate, and then you have to look at the number line to decide what to do next. So I'll just show one more example for this lecture. So if we solve these, let's say that we want to say, we'll do and or for this. So first or. So 5x greater than or equal to 2 minus 1. So x is greater than 1/5. All right. So here, greater than 1/5. So, and this is negative 1, so let's go negative 2, negative 1, 0, 1. So 1/5 is about here, and we want greater. And negative 1 is here, and we also want greater. Okay, so I drew these a little bit off-centered so we could see. Now if we want or, we want something that works here or here. So would this number satisfy or? Yes, all of these do. So if it's or, basically you include everything. You don't need to worry about it. It's all included. So if we're looking at this and we want to include everything, the answer then would be that negative 1, anything bigger than negative 1 will work. We don't need to worry about the 1/5 because that's already included in the numbers that are bigger than 1/5. So our solution is that x is greater than or equal to negative 1. Now if we did the same question, but said and, then we're looking for the overlap. So just going back, this is greater than 1/5, and this gave us greater than negative 1. So if we look at that number line that we drew, so here's negative 1, and 1/5 was here. We want the overlap where both are satisfied. So the overlap is actually here at the 1/5 and up. You see both of the lines are here. So then this solution would be that x is greater than or equal to 1/5. And this would not be part of the solution because it's only bigger than it only satisfies this one and not that. But we want and, so we want it to work in both. So the numbers in this side would work in both, and that would be our solution. Okay, we'll do more of these in the next lecture.